Today you're going to complete an ed puzzle which reviews similar figures, which we talked a lot about yesterday and did some practice of identifying similar figures and writing information in your notes. Your notebook handy will be really important as well as we venture into using proportions, which was our previous learning target, with our similar figures and solving for missing side lengths. So tools that you're going to need today are going to be a calculator, math notebook, so you can take some notes or write out some proportions and solve for missing sides, and then of course your Chromebook. Okay, so let's start off with this question. Are these two similar? So yesterday when we talked about finding similar figures, you know that you need to have two things happen in order for similar figures to occur. First of all, the shapes need to be the same. And one of the ways that you can check if the shape is the same is you can take a look at the angles. Now I notice in these two shapes, both of them are rectangles with right angles, so I would check that box off in my mind saying, yep, the shapes look the same. Next up, try to see if the sides are proportional, and if they are, then we would say that these two shapes are similar, meaning they have the same shape, but not necessarily the same size. So let's go with the long side. So if I start off with the long side of the rectangle, I know that measures at 15. And if I go with its matching or corresponding side, it would be 9. And would that match with the ratio of the shorter side? So the larger rectangle is my numerator, and then my shorter side on my smaller rectangle would be my denominator. And it may be hard to tell. Remember, there's a couple ways that you could find out if they are proportional. You could use your cross products. So you could do 15 times 6 and find the result of 90. And then you could do the other cross product, which would be 9 times 9 to find the result of 81. And then you would say no. These are not proportional because their cross products are not equivalent. We could also reduce. We could say, oh, I find the common factor of this is 3, so 15 divided by 3 would bring this down to a 5, and 9 divided by 3 bring this down to a 3. And if I find a common factor of 3 between the 9 and the 6, this would become 3 over 2 in simplest form, and again, they are not equal to each other. So while they looked similar because they had the similar shape, their ratios are not proportional, so we would say no, they are not similar. All right, let's try these two. So we have, again, shapes that look very similar. Are these two similar? It's already given you the lovely tilde sign right there, but let's verify and see. So it does look like I can see those matching angles, A to D, B to E, C to F, corresponding angles. But now I need to check the sides to make sure the proportions are the same. So if I start with A to B, its corresponding side would be D to E. So I'm going to go 6 over 9. I'll find another corresponding side as well. So we'll go with the next one as 4 to 6. And then the last one of 3 to 4.5. Okay, you can solve a couple of ways. You can reduce it as far as its lowest terms to see if the lowest terms are the same. Or we could separate them out, and if we've decided that 6 to 9 is equal to 4 to 6, and then 3 to 4.5 is equal to, say, 4 to 6 or 6 to 9, because they do all have to be equal to each other, then we would say it's equivalent. So I'm going to go ahead and I'm going to work on this one. 6 to 9 would reduce to 2 to 3. 4 to 6 would also reduce to 2 to 3. But could 3 to 4.5 reduce to 2 to 3? Now 2 to 3 is the same as 0.666 and so on. So I'm going to try that on my calculator and see 3 divided by 4.5, also the same. Each of these decimal values look like this. And we're just basically trying to find out if they are all equal to each other, whether it's in fraction form, which could be a ratio, or in decimal form. And it is. So this is a yes. They really are. That tilde is correct. time to put your skills to the test. Your question is, which parallelogram is similar to parallelogram A? Would it be B or would it be C? Or I suppose you could choose neither. Go ahead and solve. Okay, previously when we would write our problems out, we would write them along the side like this, 8 as the short side compared to 4 as the short side compared to 6 as the short side. So I just filled them in and then went with the long sides. So the long side of A, the long side of B, and the long side of C. I just filled them in within the parallelogram. And then I was able to see the ratio of the parallelogram itself from short side to long side. So as I looked through, I noticed that 6 to 12 is definitely not going to work, because 6 to 12 would reduce down to 1/2. 4 to 6 would reduce down to 2/3. And 8 to 12 would also reduce down to 2/3. So it is parallelogram B. Are these polygons similar? How do you know? So a way to prove would be to prove that either the shape is not the same because the angles don't match up, they aren't congruent, or the sides are not proportional. Decide whether or not are these polygons similar. I started off with the side of 2 compared to the side of 4, and the side of 7 compared to the side of 14, and I found that those look proportional. So then I thought, oh, let's expand that. Let's go from 7 to 14, and smaller to larger, 3 to 6. Oh, those look good. Well, let's continue on. Let's use the 3, the first figure, to 6, the second figure. Is that equivalent to the 12 to 24? And that would work as well. All to half. Proportional. Yes. Now that we can identify similar figures, we can go ahead and solve for the missing side length. Corresponding sides are proportional, so if the triangles are similar, which it says, these triangles have already been designated as similar. Your job is to find x. So let's do the matching sides. 6 to 9. And next matching side would be 8 to x. Okay, from here, let's cross product. So if I take the two sides, or the two numbers in the diagonal cross that I do have values for, 8 and 9, I'd get 72 when I multiply. So my thinking was 9 times 8. And then I have to use the remaining cross, 6 sets of x, and finish it up. Go ahead and solve for the missing side, which is x. All right, I found that the missing side value would be 12. So if I place a 12 right here, let's see if that ends up working out. So if I go first shape 6, corresponding side 9. First shape 8, corresponding side 12. Would it work? Yes, it would. 3/4 for both. Solve for this missing side. So let's start by setting up our proportion. We know that these figures are similar. So I'm going to go 12 to the corresponding side of 3, and 20 to its corresponding side of x. Solve for the missing. All right, I set up my cross products and I move forward from there. I multiplied my 20 times 3 and my 12 times x, and then divided by 12 so that I could have just one x, which gives me a value of x is equal to 5, which means this number right here should be 5. Okay, your turn again. Take a look at these similar figures. Match up those corresponding sides, use those ratios or proportions, and solve for the missing. Here is x right here. Go ahead and solve. So as I solved, I dove right after it. I said the side that corresponds with x is 40. So I said 40 is equal to x, when also choose another side to do the corresponding sides. 20 would be equal to the 4. So I put 20 down here and 4 right there. You could definitely solve with cross products. You could say 40 times 4 is equal to 20 times x, or you might even be able to look at the problem and say, oh, I know right away what x has to be. So if 20 would be 4 times 5, has to be something times 5, which means x would have to be a total of 8. Go ahead and solve for the missing side again. We have triangle MSR is similar to QPF. All right, I'm going to set up mine again. I'm going to target that x right away. So if I start off by saying the side of x is in a proportion to the missing side, or the side which would be 9, but I need to proportionalize it here. So let's go with 20 and 8. So x goes with 20, 9 goes with 8. Let's do our cross products. So I have my 20 multiplied by 9 would be equal to an 8 multiplied by x. So 180 is equal to 8 sets of x. Divide by 8 on both sides, and your missing side of x is 22 and 5/10, or 22 and a half. Find the missing side. Set up your proportion, solve for x. We've got, ooh, this one looks a little tricky. I would say that this is that match, but 70 and 50, even in this triangle, if this one is the 70, the larger of the two angles, I think this angle is the larger of the two. Ooh, I got tripped up there. If I go the larger of the two, 75 should be the larger of the two. So 75, how would this be flipped around? I think because of our side lengths, this one has to flip up, where B would be Q and A would be P. Because otherwise we wouldn't have a match for the side of x corresponding with the side of 6 and the side of 14 corresponding with the side of 7. And as you solve for x, then you would find that, go ahead and solve. Yep, you're right. X has to be 12. Good work. The way to our Monday agenda, your math work for today is done. Have a wonderful weekend. And that's it.